So now that we've talked about the most common stream factory methods, we'll talk about some of the other ones as well. And like I said, I'm not going to dwell on these quite as much because there's a lot of them, but they're more specialized. So let's talk about some other ways to make streams. One way, which is a nice example of combining together the more traditional Java I/O streams mechanisms that work on I/O, that's where it's I/O streams, with Java streams, which work on in-memory data structures, is to use some of the methods that have been added to the I/O classes in Java 8 and beyond. So for example, there's a class that's been around for a while called BufferedReader, and that's part of the Java I/O package. And historically, BufferedReader was used to read in a file, and then it would give you chunks of the file back, say in a per line method or per new line way, where you wouldn't end up having to go to the disk each time you wanted to read a new line or a new character. It would kind of buffer it and do it intelligently to speed up the transfer from a slower media like a disk into a faster media like main memory. Well, one of the things that they added with Java 8 was a new feature to the BufferedReader class called the lines method. And you'll see what we can do is use the BufferedReader to get a stream of lines which you can process using stream mechanisms. So this particular example will create a buffered reader from a given file name. So we have a method called print file lines, and you give it a file name that you want to print. And the first thing it does is it makes a new buffered reader object. And you'll notice the syntax here that's kind of interesting. It's calling this inside of a try with resources block. So there's this thing in Java called try with resources. And what it does is it allows you to be able to define a local variable, in this case, buffered reader, initialize it, and then have it be automatically closed when the try block is done. So it's a little bit like the way in which C++ has this idiom called resource acquisition is initialization, where when you create an object, you initialize it, and then when the destructor is called, it cleans it up. Well, for better or worse, Java does not have destructors. So what they do to handle this kind of scoped resource management is use a try with resources block. It's a little outside the scope of this class to talk about that in detail, but if you're curious, I'm more than happy to take questions, or just Google try with resources and you'll learn about it. There's some nice tutorials in Java about that. So the basic purpose of the try with resources block is to make sure that the buffered reader will automatically be closed when the try with resources block exits, even if an exception is thrown. And you can read about it here at this link below. The key thing I want to focus on, however, is once we've initialized our buffered reader, we can then say reader.lines, and the .lines method will automatically convert the contents of the file, which is enclosed by our buffered reader, into a stream of lines, basically a stream of new lines separated strings, and then we can do something to each of them. In this case, we're going to go ahead and use the for each terminal operation in order to print out each of these lines. Now, we could also have done other things, and in fact, this particular example isn't really very interesting unless we do other stuff after we convert it to lines, because there's easier ways of printing the contents of a file without having to turn them into streams. But in real life, you would do something between the point where you call .lines and the point where you do the for each, and you do some processing, and you could use the cool various intermediate operations like map and filter and so on. You can also do something similar with another class, which is part of the Java NIO, which stands for non-blocking IO package. And there's a class there called files, and the files class also has a lines method. And if you give it essentially the path name to the file that you want, it'll go ahead and open up that file, convert the file into a stream of new line separated lines, and then you can do something with them. So in this case, we create a stream from the file, and then for each element in the stream, we print the results out. So similar kind of idea. Again, this is just illustrating that how the factory methods work. In practice, you'd want to do something between creating the stream and printing it. That would make it much more interesting. Some other things you can do, which I actually use quite a bit in a lot of my test programs, is you can create a stream of random numbers. And there's a bunch of different variants of this. This particular one is the ints variant that creates a stream of ints, and it'll be an infinite stream of random ints. There's also a similar thing for creating a stream of random longs and so on. And what you can see here that we do is we're going to use the random number generator to make a new random number object, a new random object. And then we say, please create for me an unbounded number of random numbers in the range between 0 and 100. And you can dictate what that range is. You can make it be positive, you can make it be negative, you can make it be big, you can make it be small. You can determine how big or small and positive or negative you want those random numbers to be. They will go on forever, but of course, in practice, we typically want to put a limit on it. So in this case, we limit this stream of random numbers between 0 and 100 to be only 50 random numbers. And then again, we go ahead and print the results out. So that's just illustrating how you can use a nice random number generator with a stream to generate input. And I often use this for test programs where I want random numbers. In fact, my favorite thing to do with this is create large random numbers and then check to see if they're prime or not. And that showcases a bunch of other cool features that we may get a chance to talk about. If not in this class, in my concurrent object-oriented programming class, where we use that as the running example for many of the thread pool models. One of the most interesting ways of creating a stream, which we will cover in this class quite a bit, and you'll get a chance to use later, is the StreamSupport.Stream factory method. And what this does is it takes something called a Splitterator, which grad students are doing in assignment 1B, and everybody will get a chance to do in assignment 2A. And a Splitterator is basically used to take some input, some kind of collection, such as a string, for example, and then split it up into chunks that can be turned into a stream. So we use a Splitterator in our simple search stream program in order to create a stream that contains all of the phrases that match in the input string. So if you're looking for do or re or mi in the lyrics to the do re mi song, the Splitterator will be used to find all the places where those matches occur. And we'll talk a lot more about that later. So one of the cool things that you can do with StreamSupport.Stream in conjunction with a Splitterator is you can determine by passing in the second parameter whether the stream that's created is a sequential stream or a parallel stream. And it turns out to be easy peasy to make that choice. If you want it to be sequential, you pass in false. If you want it to be parallel, you pass in true, and boom, it'll make you the appropriate type of stream. And this is very, very powerful. For the first couple of lessons here, we're going to talk about the use of Splitterators to make sequential streams. And then later, when we get into the parallel streams part of the course, we'll talk, of course, about how you can use Splitterators to make parallel streams. Really, really cool. There's also some other stream-bearing methods that have been integrated into Java. Here's one of the ones I use a lot. This one is part of the regular expression package. And what you can do is you can compile a regular expression, and then you can say splitAsStream, and you give it a string, and then it'll go ahead and create a stream that uses the regular expression to split the string up into chunks that correspond to the elements in the stream. So this particular example is going to take a file name and a splitter, which could be a string, which might be a character or a set of characters, and it'll go ahead and read in the contents of a file, and then go ahead and split that file up into chunks based on whatever the splitter is. So for example, I use this a lot with my programs where I'm going to read the complete works of Shakespeare. So I put the complete works of Shakespeare in one gigantic file. It's like 5 megabytes in size because Shakespeare was rather prolific. And then I separate each of the works of Shakespeare by the @ sign, because the @ sign appears nowhere else in the works of Shakespeare. So it's a nice splitter. And then I use the splitAsStream method on the pattern class in order to be able to split the file's contents, which I read in as a string, into all the different works of Shakespeare. And what I get back is a stream of strings, each of which corresponds to a different work of Shakespeare. So we'll see that when we get a little further along. And I think this might be the last example of other factory methods to create streams. There's also one called generate. And generate is kind of interesting. What you can do is you can use it to generate an infinite stream of objects. In this particular case, I pass in a constructor reference. So I'm going to get an infinite stream of tree maps that map long to string. You could do other things. You could put a lambda expression in there if you wanted to do some arbitrary computation. And what you end up with will be a stream of these objects that are generated. Since it's an infinite stream, if you want to put a limit on it, you have to limit it. So we limit it to the first 100 tree maps, and then we collect that into a list. This turns out to be, again, very useful for doing generated data that you might need to do for test programs. There's other use cases for it as well, and we'll show some examples later. This type of capability is also used in the reactive streams frameworks like RxJava and Project Reactor that we'll cover later in the course, although the particular API mechanism is a slightly bit different. It's often used in those contexts to be able to bridge the world of imperative programming with the world of reactive streams processing, and you'll get a chance to learn more about that a little bit later. Okay, so that's the end of the overview of other Java streams factory methods. At this point, you know pretty much every different way there is to create a stream. There's a few other mechanisms lurking, but we're going to focus primarily in this class on stream and parallel stream and a little bit on the splitterators here and there. The other methods are useful, but they aren't as common as the ones that I've covered so far.